Basic programming concepts and designing programs. Today we're going to talk about basic programming concepts. This is mostly going to be a review of what we talked about earlier in the semester. We're also going to talk about what we really did in Lab 3. And finally we're going to go over designing a program. So back to the beginning. Objects. Objects or sprites can be described with properties. They also have behaviors that can be commanded. Looking at the example, you can see that some of the cat's properties are the x and y positions, the direction, and size. Those are listed beside the actual picture of the cat. Now a few things that the cat can do are move, turn, say, think, or ask questions. These are all behaviors that can be commanded through instructions. Next we have variables and operators. Variables store a value. Now once a value is stored in the variable, it can be changed. It is usually changed with an operator. Operators can compute or compare values, set or change the variable as well. Now let's look at the examples below. Here, when we do 4 plus 5 using the addition operator, we're computing a value. 4 plus 5 is essentially the same thing as 9. Now going to the example on the right, here we're using the set instruction to set x equal to 4 plus 5, which is essentially setting x equal to 9. Now the last example we have is going to be comparing values. Operators such as is equal to, is greater than, or is less than, all return a true or a false value. Right here we have x is equal to 9. Now this will be true because x is equal to 9. If and if-else instructions. If instructions do something if a condition is met. So in the example below, we set x to 4 plus 5, which as we said before is 9, and then we see if x is greater than 9, and if it is, if that condition is met, we move 10 steps. Now the else instruction is what we do if the condition is not met. Now looking at the program we have, since x greater than 9 returns false because we know that x is equal to 9 and not greater than 9, it will not move the cat 10 steps. Since we don't have an else instruction, it won't do anything else. The program will just end. Now loop instructions. Loop instructions repeat a set of instructions and they stop when a condition is met. Below we have 3 examples that make the cat move 10 steps 10 times. The first one is the basic repeat a certain number of times instruction. We put the move 10 steps instruction inside of a repeat loop that repeats 10 times. The second instruction is a little more complicated, but essentially does the same thing. We start off by creating a variable called count, and we set it equal to 0. Then we combine the loop with an if condition, and we check to see if count is less than 10. Now what forever if does is that it repeats forever if that condition is met. So as long as count is less than 10, that loop will keep repeating. Now within the loop, we move the cat 10 steps, just like in the other one. But what we also do is we change count by 1, which essentially increases count by 1. So what will happen is that the first time it goes through the condition, since count is initially 0 and it is less than 10, it will move the cat 10 steps, then increase count to 1. Then it will loop again and check the condition again, and count now is 1, but it's still less than 10, and it will keep doing this until count is equal to 10 and is no longer less than 10, and it will exit the loop. Now let's look at the third example. It does a repeat until a certain condition is met. So in this example it does repeat until count is equal to 10. So very similar to the example we just talked about, it will move the cat 10 steps, it will increase count by 1, and it will check the condition again. Now it's going to keep increasing count by 1 and moving 10 steps until count is equal to 10. And once it does that, the loop will exit. Now let's talk about what we really did in Lab 3. We gave you a problem, Then we gave you step-by-step instructions on how to solve that problem. And then you wrote a program that essentially solved the problem. So essentially, you created a program. The next thing that you did is that you made sure it worked. You did this by testing the program, seeing if you got the result that you expected, and along the way, you tested it, which is essentially debugging. Now there's a third step in the process of creating programs, and that's actually designing the program. In the real world, you get a problem, but you don't get steps. You don't get instructions on exactly how to solve it, and you have to come up with how to create the program yourself. And this is called design. You must be able to design your own solution. What is designing? Designing is deciding what the program will do and how it will do it. Now there are a few things you need to decide when you're in the process of designing a program. A few examples are, what will the program accomplish? How will the program start? What inputs will be provided? How will the program end? What objects and variables will you be using? And what set of instructions will the program run? Determining all of these things will help you design your program. Now let's look at a problem that we talked about earlier on in the semester, making a cat ask a question. Let's go through some of the design steps. So, what will the program accomplish? Well, the cat will ask a question, take an answer from the user, then say if the answer is correct or incorrect. Next, let's see, how will the program start? Well, when the green flag is clicked. Now what inputs will be provided? The user will type an answer to the question. What objects and variables will be used? The cat will ask the question and say if answer is correct or not. These are some examples of the instructions that will be used to solve the problem. The answer variable is what stores the answer from the user. Now when trying to figure out the set of instructions that the program will run, it's sometimes easier to write it out on paper instead of going straight to Scratch. Now to do this you can use a very simple language, something simple enough that you can explain your program to someone else. Below is an example of a program where the steps are written out on paper. Let's go through them quickly. Start the program. The cat will ask, what is y if y is equal to x times 4 plus 12 and x is 3? Now you wait for the user's input and you get the answer. Now you're going to check your answer. If the answer is equal to 24 is true, cat will say correct. Now if answer is equal to 24 is false, the cat will say wrong. Now you can create your program. The next step would be to use this outline to create a Scratch program. The last step you want to go through is to test your design. You want to check to see if the answers that you're getting are what you expect. So here are examples of two different tests you can use to see if your program is correct. Try inputting 20 as the user and see if the cat says that it's wrong. Try inputting 24 and see that it's correct. So today we reviewed the basic programming concept that we've learned throughout the semester. We also went over what we did in Lab 3, which was creating a program and testing it. Lastly, we went over the third step, which is designing a program. That's all for today.